A.REI.3. This is Algebra, Reasoning with Equations and Inequalities, Part 3, Video 1, Solving One-Step Equations. Please pause the video and write down these terms and define them in your journals. And also pause the video here and write down the properties of equality. These are the inverse operations for your 4 operations of addition, subtraction, multiplication, and division. And I'm going to be showing you a little bit about how to use inverse operations and these properties to solve one-step equations. First, we're going to start off with addition. Even though you see in the equation in red that you have a subtraction sign, we are going to use the addition property of equality to balance the equation, or in other words, solve for x. We want to figure out what the x value is. Maybe you can think about it in your head right now. What subtracted by 5 is equal to negative 17? Well, I like to draw this invisible wall, write down the equal sign, and that creates 2 sides of the equation. And on the left side, it looks like we need to be rid of the negative 5 and make it into a 0. We want x by itself, so we are going to do the inverse operations to make that happen. So the inverse or opposite of subtracting 5 is adding 5. And if I add 5 to the left side, I'm also going to add 5 to the right, and that balances out the equation. Negative 5 added to 5 is 0, so that has been eliminated, and I'm left with this x equaling whatever negative 17 plus 5 is, which that happens to be negative 12. And if you'd like to check your solution, you take the x value of negative 12 and put it back into the original problem and follow the operations as they state. So negative 12 subtracted by 5 should be equal to the right side, and it is negative 17. So that solution checks. On the right side, again, we're going to begin with our wall, and I threw in some decimals. I asked you in class what you had the most trouble with, and you seem to be having trouble with the decimals and fractions. So I've put a few of those into this flip chart for you. Same process, property of equality. I'm subtracting 4 6/10, so I need to be rid of those so that I can end up with just 1w, and the opposite of subtracting would again be adding. There's my addition of 4 6/10, and I also do it on the left side. On the right, we end up with 1w, positive 1w, and then on the left, I have to do a little addition of negatives. So if you recall, when you're adding opposite signs, we are going to do the opposite operation, and we're going to actually subtract these 2 decimals. So let's not worry about the sign as of right now. Let's just line up our decimal points and subtract, and we end up with some type of 1 1/10. Some type. Let's figure out if it's going to be positive or negative. Think back to the absolute value when we added integers. We take the higher absolute value sign, so the absolute value of the first term is 5 7/10, and the absolute value of the second is 4 6/10, and 5.7 is larger, so I take its sign in the answer. So we have negative 1 1/10, and you can go and check out your solution, make sure it works. Okay, subtraction. Now we're going to be using the subtraction property of equality, and you could probably guess it's going to be the opposite, which would be addition. The problem on the left, we have a negative 3 and 2/10 with our z. I'm not looking at the sign in front of the z to tell me what to do. I'm looking at the sign in front of the constant to tell me what to do to get rid of it. So to get rid of my negative 3 and 2/10, we're going to do the opposite of negative, and that's going to be adding. So negative 3 and 2/10 added to, and then our z. And on the right side, we're going to also have to add 3 and 2/10 to balance it out. Let's see what this looks like. This eliminated it or made it 0, and we have z equaling, once again, we have these opposite signs and the addition procedure, so let's go down to the bottom. Opposite signs mean we're going to subtract them, line up the decimals, and we get some type of 4 and 2/10. Absolute value, both of them. The 7.4 wins out, so I steal its sign in the answer. We have negative 4 and 2/10. On the right, I threw some fractions in there for you, same process. I need to get rid of this 1/8. Don't look at the sign next to the V. Look at the sign in front of the 1/8, and it's a positive, so to get rid of that, we need to subtract. So we have 1/8 subtracted by 1/8, and then 3/4 subtracted by 1/8. All right, 3/4 and 1/8, I need common denominators. Come down to the bottom. I like to do it vertically. Common denominator is 8. Equivalent fractions, 4 goes into 8, 2 times 3 is 6. So we have 6/8 minus 1/8, which is 5/8. Check for signs. Signs are not an issue because we have a larger fraction deducted by a smaller fraction, so we're good. All right, moving on to multiplication. I have fractions within my multiplication properties. I guess the simplest way that I've taught is to multiply your denominator times your whole number, and that's going to end up with your numerator. So 5 times negative 3 is going to be 15 negative. So negative 15 would be the answer here. Negative 15 divided by 5 is negative 3. However, I want to show you another way. That's kind of the quick way. I just want to show you the mathematical reasoning behind that. So let's clear that off. We know that there's a 1 touching the x. It's invisible. And in order to get rid of a fraction touching a variable, you multiply both sides by the reciprocal of that fraction. So the reciprocal of 1/5 is 5, or 5/1. And if you do that to the left side, you also do that to the right side. So negative 3 multiplied by that reciprocal, which was 5/1. Your 5's cancel. You're left with your 1x. Multiply across. Over 1, and then simplify. Okay, so we came up with the same answer. This was the longer way, but again, I wanted to prove to you that multiplying by the reciprocal will get you the same answer as your quick multiplication. Next problem. Same idea. We have a fraction touching the variable that is multiplying, so we are going to get rid of this fraction by doing the inverse or the reciprocal to both sides. So negative 7/2. All right, so look at all the canceling going on here, and you got your negative times a negative, which is a positive. So cancel, cancel, all into ones. So 1x is equal to, what do we have? 28 over 2 with a negative anywhere within there. So we have x equaling negative 14. Remember, you can always check to go, put the answer back into your original equation and see if that negative 14 is actually the answer when you multiply that out to get 4. All right, last one here on the right. Same idea, we have a fraction touching a variable. We would have to multiply by the reciprocal on both sides. And simplify. 3/5. Division. Still working with inverse operations. The opposite of division is multiplication. So I see here that I have a 5 touching a G. We are going to do the opposite, which is divide then by what's touching the variable, and that would be a 5. So the 5's cancel, G is equal to 4. Now we worked a lot with that last year, so that shouldn't be too new to you. I threw this up here because I wanted to do some decimals with you to kind of remind you how to work with decimals. All right, so let's divide both sides by that coefficient of negative 4. So G is going to equal whatever this is. A positive divided by a negative, I'll just throw right in the answer right now, some negative value, and then go off to the side of your paper and do your division of decimals. So let's take this 8 2/10 and divide it by 4. Let's see how that works out. So bring your decimal up. 4 goes into 8 2 times. Subtract. 4 goes into 2 0 times. Bring down your 0, and we have a 5 and no remainder. So G is equal to negative, bring down that 2 5/100. All right. Little reminder on how to divide decimals. Okay, in your journal, I'd like you to define the given terms that I had on page 2 of the flip chart and write a few sentences on what you learned from the video. And as always, if you had any questions, please write down questions from the problems that you saw in this video, and I can show you with some similar problems in class.